So you're out in the world and you see a bird walk by and wonder, why are its knees backwards? Many kinds of birds have this structure, from doves to robins to herons. The answer is, that's not their knees, it's their ankles. Just like in humans, the ankles in birds bend backwards and their knees bend forwards. Only in a bird, the knee is much higher up, close to the body and under the wing. If that leaves you scratching your head, as it did to me, consider this picture of a hawk. Although the knees aren't flexed, you can get an idea of how high up it is and why it would be otherwise hard to see. There's 3 basic ways to increase stride length in animals. First are animals that are unguligrades. This includes animals that walk on their tiptoes and usually have hooves, such as deer. Then there are digitigrades, which includes the majority of bird species. This means they walk on their toes, not with the soles of their feet. This is actually more common than you may realize. Dogs and cats are the same way. And lastly, there are plantigrade species, which place the full length of their foot on the ground, like humans, bears, and squirrels. To keep these terms straight, I think of ballet shoes as a metaphor. Unguligrades are on pointe shoes, digitigrades are on the balls of their feet, and plantigrades are flat-footed. The length of the bones is what makes it so different. The toes, or digits, in birds are long, and in some birds like the jacana, their toes are really long so they can walk across floating vegetation. Moving up from the digits, there is a bone called the tarsometatarsus, which is found only in birds, and is the fusion of multiple bones. It gives the ankle more length. In humans, this would be the tarsals and metatarsals, but ours are significantly shorter. From there is the tibia that's fused with some of the upper foot bones to form the tibiotarsus and is alongside the fibula. And then there's the femur. But look at it, it's really short. In humans, the femur is the longest bone in the body. Not the case with birds. No wonder we can't see their knees. As a side note, the family of birds known as thick knees or stone curlews is a misnomer. Their thick knees are actually just large heels or big knobby ankles. And lastly, what's the purpose of birds walking on their toes? There's room for discussion here. I think it must be to allow them to move more quickly, especially when foraging on the ground, in a tree, or in water. Having less surface area in contact with the ground means having less reaction time. This is also useful when escaping predators. The sole of a plantigrade foot provides a sturdier base for bearing weight. Think of the difference between walking, running, and sprinting with how much contact your foot has with the ground. Here's an interesting example. At some point, you've probably seen a dove or pigeon sitting all the way down. In this case, it's resting the whole length of its foot, but when it gets up again, it goes back to being on its toes. It makes sense why a flat-footed dove just wouldn't work for getting around how they need to. It's fine for resting, but slow and inefficient otherwise. This topic is just fascinating, and I hope you enjoyed learning about it. What do you think some other benefits are for having digitigrade feet in birds? Feel free to leave a comment down below. Thank you for watching. That's all for this time. I'll see you again soon.